So today this session really is to bring together some insight from some of our network partners with regards to our flexible fund that we've got available. So I'm just going to take us through a brief overview and then we'll get on to the lightning round so we can hear from the people that we want to hear from. Then Lee Rong from our network team will provide a short overview of building collaborative proposals, and then we'll move into a general discussion and Q&A. So if you have any questions along the way, if you'd like to pop them into the chat, or keep them for the Q&A, and you can come off camera and off mic at that point. So next slide. Thank you, Kate. So yeah, I'm Georgie Hopkins. I'm the DICE Network Manager, and I'm just going to run us through a brief overview. As most people probably know the details of the DICE Network Plus, but we are a 3-year EPSRC funded network. We're just at the beginning of our second year now. We had a number of partner organisations who supported us in the funding proposal element, and given our first year of activity, this network group has grown substantially already. We're a base of 9 universities led by the University of Exeter, with 8 other universities and 11 academic partners across the whole of the UK. Our key focus really is about leveraging the power of the digital revolution to drive the circular economy across sectors and value chains. And if we move to the next slide, we can see there we're addressing 2 key challenge areas. So the first one is around embed, which is around how we embed sustainability and circularity in the design and development of new digital technologies. And the second one is around enable. So how are we realising the potential from the digital revolution to enable the circular economy across different sectors and overcome some of those common barriers that we're aware of. So if we move to the next slide, the focus today is our flex funds. So as a project, we had £450,000 to distribute through these 3 different funds: knowledge exchange placements, feasibility studies and demonstrators. We still have, we're expecting to fund, we've funded 6 knowledge exchange placements with funding for another 6 to follow. They're on rolling applications. Next deadline is the 9th of March. We've got 3 more feasibility studies with 3 funded, and that's what we're really focusing on today. And the deadline of that for the next application is the 27th of April. And similarly, we've got funds for 2 demonstrator calls. So these are really moving beyond that feasibility stage where initial research has been completed and moving into sort of tangible demonstrators. And we've got funds for 2 demonstrator projects, again, same deadline. The full details of these are on our website. We'll provide the link later as well. I would encourage you to look at the details there. So I won't hold on this page, and we'll move to the next slide, please. So the feasibility studies, we've got some areas of focus that the network team have identified. And just to be really clear, these are not limited to these areas, but these are just some areas that we are looking at in more detail across our deep dives and wider work. So one is around data centres and material intensity and e-waste. We're looking at space around extending the use of and end-of-life recovery of critical raw materials. We're looking at renewables, again, extending use and end-of-life recovery. Semiconductor sector with component manufacturing and substitution, and the telecom sector around consumer device take-back and end-of-life materials. So we're particularly interested in studies that may look at these areas, but like we said, not limited to those. And the next slide, please. So demonstrators, some areas of focus here, we're really looking, again, I won't go through this in too much details, but looking at those digital technologies that enable innovation, particularly around AI and machine learning to accelerate adoption, looking around digital technologies which accelerate the adoption of product as a service models, the use of digital technologies to gather evidence for implementation of circular economy initiatives, and also around that socio-technical aspects of new circular digital system adoption. Again, full details are on our website, so I'd encourage you to go and review there. And thank you for my last slide. This is a really important one. So this is about our research ambition. So we as a network are really keen to undertake speculative and potentially high impact research to accelerate our move to the digitally enabled circular economy. There are 4 objectives under there: that this research should take a whole systems approach. We'd like to ensure the research results in increased confidence in the concept that's been developed, really importantly, because of our drive towards an inclusive community, is that they be led by an early careers researcher, or at minimum have an ECR who's playing a very active participation in the project, and also including at least one industrial partner, government or third sector partner. So we're really addressing real world impact. And those last two key points there are really important. And that's really the focus of this webinar today, because from our first funding call, we found that this connection between the academic and industry and government and third sector can sometimes be challenging. So we wanted to use our kind of position within the network to try and share more information and create some collaborations here. So we've brought together today a number of our key DICE partners who are really kindly going to share a snapshot of the real world challenges that they face. And this is really about providing some inspiration towards developing those collaborative research projects based on really addressing these challenges. So I think from my side now, it's just to say thank you very much to our partners for giving our time. I'm rushing slightly because Astrid Wynne from TechBuyer is up first, and she's on a real tight timeline. So she's just going to give us an overview and then have to dip out. We will have Q&A afterwards, and for Astrid in particular, we'll pass along any questions and provide introductions after this webinar. So no further ado, Astrid, over to you to take it away. Thank you.
Thank you very much. So from a TechBuyer point of view, we deal with refurbishment of servers, storage and networking in the data center sector. And these piece of information I'm going to share today challenge the assumption that when you have new technology, you have this raft of e-waste, which is then destroyed instantly. Actually, the opposite is happening right now in the secondary market for enterprise IT hardware. Because AI workloads are demanding more memory and more processing power, you're seeing an increase in demand in memory at the moment. And that is coupled with the fact that they've just made one of the memory generations obsolete. So now a lot of customers are looking to the secondary market to supply memory at scale because they need it. So we're having, a boom time in the secondary market. As a result, you can see some of the analysis on this and background to this on this slide. So if we move on to the next slide, what does that mean globally? Well, the secondary market's well positioned to deal with demand. So they have certification processes in place to make sure that memory is what it should be. That we also have some research on how you can upgrade existing machines with memory to make them more performant. The challenges are around traceability on that. When you're looking at globalized supply chain, which is based on reverse logistics through a marketplace, trying to understand where things have come from and where they're going to, it makes it very difficult. From a sustainability standpoint, it makes it very, very difficult to understand how much is reused and how much is recycled. And for scaling into a customer market, you need to establish trust. So that traceability is really, really important. We need digital solutions for that traceability. Governments are already looking at that, but the nuts and bolts of that are unclear. So this then leads on to an opportunity for research to boost the capability of the secondary market to answer this increased demand as technology changes. The other thing I'd mention here is what we're seeing now in memory may well be seen in processors and storage at a later date. So that's important to bear in mind. Next slide, please. So collaborative research and demonstrator opportunities that we as a group, as a wider group, not just TechBuyer in the room, established as possibilities. So looking at an interoperable data model. So multiple organizations can feed into a centralized repository that enables that traceability. That's more difficult than it sounds, both technologically and culturally, to get people on board with that. An early warning demand supply model would be useful as well, so you could predict what's actually going to happen in the market and then make sure that your technological capability across multiple stakeholders is there. Reuse first, upgrade optimizer, looking at ways that you decide when something is good enough to reuse, when it should be downgraded into a different system, when it can be used to rebuild a new system for higher compute demand. And that's going to require industry and academia collaboration, not just a single industry representative, but multiple industry representatives to get that right. Thank you.
Fantastic. Thank you, Astrid, and thank you for joining us. I know that you've got to dip out now. It's really interesting, isn't it, that we're seeing that material supply challenge already, particularly across that secondary market. Yeah,
in an unexpected way as well. Okay,
yeah.
Thank you very much, everybody.
Thank you for joining us. Thank you.
Bye.
Brilliant. So these are rapid fires. So I'm going to move over now to Stefan Larsson from Lenovo.
Yeah, thank you very much, Georgia. And let's work on to the next slide, because as most of you already have seen and also have noticed, that AI is taking more and more of not only the agenda, but actually our everyday life. And one of those things that is very special about AI is, of course, that everything is driven more or less from the data centers. And what is also very clear is that it is putting a lot of demand both on data centers in general, but on power in specific. And I gathered just a little bit of interesting information for all of you, just to see how much it actually will affect. So if we look into it, actually, Gartner have projected that the energy demand will actually increase and grow to more than 16%, as already did in 2025, and double already in 2030. And that in itself is just a projection. What we are already seeing right now is that maybe that projection is underrated. Maybe it will grow even further. And of course, what we see is that the capacity will have to be doubled, nearly 100 gigawatt of new data center capacity over the next few years because of AI. What is also interesting to see is we're starting also to see some challenges around that. For instance, in Asia Pacific, they face supply gaps. What we also seen around some of the areas where the data centers are located are what we call blackouts, basically short period of times where the whole community is without power. And of course, one of the things that is the challenging part here is we need data centers, we need AI, and I think it's going to be very difficult to tell people not to use AI. So what does it actually mean? Well, all of this really means that the demand for data centers will and is accelerating because of AI. We'll also see that the infrastructure will require huge investments on a global scale, both from the government and from the private sector. And what we also see is the rising demand for electricity and power. And at the same time, also, we can see some indications that the price of power might also follow that. So basically, there are a lot of, let's say, demands to the data centers because of AI. First of all, we will see that, or we already see that there is an increased demand for GPUs and specialized AI chips. Most of you who follow a little on the stock market, you can see that on the manufacturers that actually manufacture these things, the stock have gone quite high. We can also see that higher power consumption and advanced cooling systems, because that's the other part. Data centers need cooling systems. And the expansion of hyperscale data centers is already there. And we in Lenovo, we also see that clear indication. And last but not least, of course, it adds for us as a manufacturer, as a vendor, to actually create more sustainable and energy efficient data centers in the design. So where has that led us to in Lenovo? Well, if we jump to the next slide, please. One of the key areas that we have been developing for quite some time is actually our product called the Lenovo Neptune, which actually is a water-cooled server. And the water-cooled data center is something completely new. And the reason why this is smart is basically because it uses 40% less power and thereby 40% less CO2 emission. And the smart thing about this is actually it adds to that very difficult, let's say, challenge around a data center, that it uses less power and emits less CO2. And less power means less cost in operation. But also the fact that some of the data centers simply are operating so high that air cooling is not possible. And that is why water cooling is the new technology that we will see progress quickly and already now are seeing huge interest from. So in the note, of course, we say, how can we expand that even further? Because we know that there is a demand around these data centers, but we also know there is a desire to say, how can we expand that technology even further? And if we move on to the next slide, please. We already now are working with a lot of companies around using that warm water from the servers or data centers into using it to heat up buildings and so on and so forth. And the reason why we are looking into this is actually it's creating a brand new sustainability approach. The fact that we can reuse the hot water again, send it back, and then cool down the server and reuse that hot water makes this not only a fantastic sustainability solution up front, 40% less power consumption, but also the fact that we can reuse the hot water as a secondary sustainability option. So this is here, it's the future, and we're going to expand that technology even further. And driven by the demand for AI, it's a natural next step. Thank you.
Thank you, Stefan. Thanks for sharing that insight and that development there. That's really interesting to see as we move forward. I'm conscious of time, so I'm going to pass over now to Minnie Rye from Orbit Rise. Thanks, Minnie. We can see we've got your slides, space debris at the moment. There we go. Fantastic. Oh, you're on mute. Sorry.
Thank you. Thank you for the introduction. Today we are going to explore the need for circularity in space. And if any of you are interested in this topic, do reach out at the end of the workshop, because I'm interested in supporting a feasibility study on this topic. Coming to the problem of space debris.
Minnie, sorry, you dropped back onto mute. There we go. I think we've got you.
Yeah. So space debris originates from derelict rocket bodies, upper stages of launchers, and spacecraft abandoned in space. Objects of all sizes are indeed a threat, and anything larger than a centimeter can severely damage an operational spacecraft or a launcher. So the larger the object, it means, the greater the risk of collision with another operational spacecraft. And we need to act very soon, because this problem is escalating. And this is because the space sector is rapidly growing, expanding with several mega constellations. New commercial services are growing, and therefore there is an increasing reliance on satellites. With this growth actually comes a greater pressure on how we can use the resources and reduce the risk of potential orbital collisions. In my view, removing large satellites or large number of space debris from orbit and letting them deorbit and splash down somewhere in the specific is not a sustainable approach. And this is the reason I'm very passionate about circularity in space, because if we continue with that practice, it will introduce a significant amount of metallic pollutants in the upper atmosphere, and this can pose it is indeed an emerging threat to Earth's ozone layer and also climate change. Moreover, it's also harmful to the marine life. So how can we actually address this problem to avoid what we call the Kessler syndrome, which is a cascading effect seen when debris collide? So what we need is something that is more eco-friendly, and we need to tackle this solution in a more digitally friendly way. So if you look at, say, for example, different materials that we currently use for building satellites or launches, we use chrome and nickel steel alloys extensively. So is aluminium and its alloys. The question is, can we actually reuse, repurpose, or recycle space debris to manufacture new parts and components in space? And if so, how do we then establish a circular space economy? Now, there are various studies on this topic. So this is not something I'm introducing. There are various studies in this area. So circularity directly strengthens resilience in space, and it reduces long-term cost. It protects the orbital ecosystem on which the entire downstream space applications rely. So as you see on this screen, on your left side, it's the demonstration of the space debris. So for example, we can track them. We are developing a range of robotic and autonomous systems technology for capturing them. But the question is whether we want to really let them deorbit and burn out in the upper atmosphere, or can we actually do something more practical in the orbit itself, by using advanced robotics and AI to disassemble, recycle, or reuse parts and facilitate in-space manufacturing of newer parts and components. So this means there is a real need for using advances in digital technologies, particularly robotics, AI, and material science or material technology, to enable in-space manufacturing and enable thereby establishing a circular space economy. In June 2023, His Majesty King Charles unveiled the Astra Charta, and in collaboration with SE, BSI actually created a new standard for space sustainability. Shared standards will help to unlock an entire in-orbit services market. If industry and agencies can work together around these standards, then circularity becomes it can become achievable at scale rather than in isolated effort. So in my view, engineers and policymakers must be able to view the entire mission's life cycle, starting from design, manufacturing, and operations, all the way to the end of life, not just the end of mission. And this is because circularity actually sits at the intersection of all this. Above all, we need to see that space is a shared resource, and therefore, when we design spacecraft, we need to make sure they're designed to be serviced in orbit, they're modular to be serviced, and they're interoperable right from day one. To conclude my talk, I must emphasize that circular economy is not only for long-term sustainability on Earth, but also in space. So sustainable practices will help to apply digital technologies, and this will help mitigate any risk associated with even climate change. So with that, I would like to conclude my short talk, but feel free to reach out in case you're interested in exploring the topic of circularity in space. Thank you.
Minnie, thank you so much. That's fantastic to hear about, and quite literally a whole new horizon for circularity. So yeah, we'll be sharing contact details after the webinar. Thank you. And I think now we're going to move on to Simon Brown from Sustainable Ventures. Okay, we're just on the, oh yeah, there we go, perfect.
Okay, thanks, Georgie. Am I coming through?
Yeah, we can hear you. Yeah.
Good to go. Okay, great. Yeah. So yeah, do skip to the first slide. Yeah. So I suppose the point here is we're really on the side of the entrepreneur in this. We're actively growing an ecosystem of climate tech, early stage and scale up businesses. We operate out of a major hub in County Hall, London, about 1,000 people there. We've just launched a new hub in the UMIS building in Manchester. Any engineers will probably recognise the building we've sort of taken over, and we're about to open in Glasgow in the Lighthouse building. So, yeah, we're on a mission to build this ecosystem and stay on the side of the entrepreneur. So, next slide. We sort of do this by bringing together three things: those workspaces, great places to work, great places to sort of share and exchange knowledge between innovators. We directly invest into companies, and we help founders raise further funds. And we run support programs. So National Climate Tech Accelerator, we launched that in November of last year. We've got over 200 companies signed up and getting support through that program. Next slide. This is really just to say that climate tech is quite a broad church with sort of 7 really clusters growing and evolving, including circular and biocircular, and some of these themes like circular economy cut through many other themes. But yeah, a large number of companies, all kind of very exciting. Next slide. So some of our lessons around the circular economy, and I suppose one of the things we would be looking to get out of this research are updated views on how to avoid some of the hard lessons, and whether we're on the right track with some of the new directions. So we learned the hard way that B2C businesses in circular economy are hard to scale. Circular economy platforms, digital only, really hard to pick winners, and the kind of pure play digital innovation is quite hard to defend. We've seen some really interesting success, growth, scale in some of the circular economy. There seem to be some defensible niches, some sort of opportunities to play into the circular economy kind of value chain, if you like, through things like RFID, and possibly the dawn of a kind of new era on circular and biocircular materials. The current thesis where we're investing is into areas like advanced manufacturing, advanced materials that have a significant role to play in any kind of circular system, nature-based solutions, climate repair, to try to address the growing emissions from the sector, and this really fascinating area around the AI, machine learning, hard tech hybrids. I'll just explain that a little bit more on the next slide, please. Yeah, so here really, AI and climate tech. Climate really is a hardware problem. We need physical things to tackle many of the issues there. But there's a really interesting picture coming in here. So AI kind of business model dependency for some companies that we invested in a company called Ignota Labs. They're a sort of discovery engine. Without AI, they wouldn't exist. So very, very dependent on AI. Danu robotics business, able to do things that years of machine learning, and now embracing AI, they can do things that just weren't feasible even a year ago through this combination of robotics and AI. And then companies like Solivus, flexible solar solutions that are able to use AI to provide services to optimize around flex and peak and demand, supply, storage, and what have you. So we're very active trying to look for companies probably in the sweet spot in the middle there of that AI pyramid. Then we look into this sort of digital innovation value chain opportunity, seeing a lot of interest in advanced materials. Lumiere is a Glasgow-based, Scotland-based company developing neuromorphic chips, sort of this area of photonics. AI race is really an energy race, and they're trying to massively sort of increase the amount of computation that you get from a source of energy. So that's quite exciting. We've got some interesting businesses sort of in the guts of recycling, resource recovery, you know, extracting metals from water waste, or keeping kit in circulation for longer. And then there's some interesting stuff around advanced energy. You know, Super 6 is basically energy storage on a scale and efficiency that will make a huge difference to this. We still see major challenges. You know, ultimately, systems innovation, circular economy has to be addressed through systems. I'm preaching to the choir here. We've seen some interesting success in circular outside of this value chain in food, where we're able to bring together, you know, major corporates, innovators, grant and debt providers, investors, NGOs, charities, to try to create a multi-year pilot program to build scale in circular economy systems, in that case around food, but there's no question we could do something similar in this space. Ongoing challenges around the finance gap. You know, we're really good at funding research. We're above our weight on that in the UK. We're quite good now at taking research out into early commercialization, but we still struggle to get the bigger amounts of money to fund the bigger bets that come when you're trying to scale circular economy solutions. So we really need to improve on that. And then the other thought is a lot of the innovation around circular economy and digital is the parallel value chains around resources, around waste, around energy, and so kind of really important that we do that. And then last thought is this sort of one about, I'm going to call it eating your own dog food. You know, what we're trying to do in SV is we're trying to show that it's possible. So those sort of wonky looking bricks there, bricks that have come out of Manchester University research that are being manufactured at small scale in Manchester and are now part of the fabric of the innovation hub that we've built in Manchester in the Renault building. So, you know, there are opportunities, and you've got to kind of live it, and we're trying very hard to do so. So we're really keen to support access to innovation into this research, to get involved in the systemic nature of it, and see if we can drive progress along the themes that Georgie you've shared. Thank you.
That's great. Thanks, Simon. Really, really interesting and valuable insight, I think, into that kind of next level. Once we come out of feasibilities and demonstrators, where do these opportunities go and develop, and still the fact there are challenges around growing and advancing in those areas. So I think we'll move on to Andy Duncan from Openreach, who's kindly going to share the next short insight. Good, we can see your slides. Thanks, Andy.
Perfect. Yeah, thanks for having me. So for those less familiar with Openreach, we build and operate the UK's digital access network, the copper and fibre cables, ducts, poles and cabinets connecting around 30 million homes and businesses. And we're delivering one of Europe's largest full fibre programmes through our Reach 26 strategy. So we're on track to pass 25 million homes by 2026, or the end of this year, with an ambition to reach 30 million by 2030. Sustainability, as you can see on our screen here, is one of 4 core pillars of our strategy. But today, of course, I'm going to focus more on the circularity part, or as we like to call it, using less and wasting less. So this is a quick tour of the easy wins, the tougher trade-offs, and the challenges that we haven't quite solved yet. So avoidance really is the biggest circularity win for most people, but at a national scale, when you're building the UK's largest fibre network, our biggest footprint isn't fibre, it's actually the civils. So the digging trenches, installing ducts, poles, and chambers that you see in the street. So the strongest lever that we have is avoiding civils really wherever possible. So we do that by using duct cameras instead of digging, clearing blockages rather than excavating, using things like desilters, essentially a large jet wash. Smarter routing, blowing additional fibre through existing infrastructure, and combining multiple connections into single cables to reduce infrastructure required. Of course, all of this means fewer trenches, fewer materials, fewer emissions, and less disruption for our customers. So we then obviously move on to reducing when digging is unavoidable. And when we do have to dig, we focus on reduction. So that includes micro excavation instead of full trenching, tighter route planning and efficient design, and reducing material inputs at source of the components that we install. Across our supply chain, we're also miniaturizing our equipment, so making the equipment that we install as small as possible whilst staying effective and holding quality, removing unnecessary components and eliminating single-use plastics in our top 25 items, which we've done last year. Of course, every gram that we don't introduce is a gram we never need to manage as waste. So it's the quieter side of circularity, but it compounds when you're building at the scale that we are. We then come on to retiring our legacy infrastructure. So as we move from building our fibre network and connecting across the UK, we then retire our copper network. And as the legacy equipment closes, our exchanges need to become less and less. So we're closing exchanges over the coming years and decommissioning large volumes of equipment. So of course, we work with specialist UK WEEE processors to recover valuable components, refurbish any usable equipment, and extract precious materials, and of course recycle what we can. The easy win here, I think, for retiring a network like the copper network is copper recovery. So one major success story for Openreach and circularity in the UK is recovering that copper network, and there's hundreds of thousands of tons of recoverable copper in the ground. And of course, as we all know, copper is critical for EV charging, renewables, and national infrastructure, and to stopping extracting raw copper and impacting nature on a global scale. So we're extracting and recycling it. So of course, it re-enters supply chains. We have a processor in the UK that processes the cable back into copper, and then the actual raw synthesizing the copper back into its raw material is done outside of the UK. It's one of those rare moments where sustainability and finance align perfectly. The hard part, so the challenge, is actually fibre optic cable waste. So it's the challenge we haven't fully cracked yet, and I don't think anyone in the industry really has. The challenge that we haven't cracked is really that to deliver fast, reliable fibre installs, our engineers use pre-terminated cables. So cables with a factory-fitted end, a connectorized block terminal, or a screw cap, which is connected in the factory. Now, of course, this has many sustainability benefits itself. It gives us lower fault rates and less need for intervention, faster installations, which is better for the business and our customers, and consistent customer experience. But they have to come in fixed lengths. So if a route is estimated at 55 meters, let's say, to a customer's property, the engineer may take an 80-meter cable, and there's reasons for this due to customer layout changes, obstacles that we may not face in the digital network as opposed to the real network, and we have to connect to customers first time. That's our main obligation. Taking a shorter cable risks a failed install, another van journey, increasing our emissions back to one of our sites. So operationally, it's the right choice, but it leaves excess cable, sometimes 5 meters, sometimes 30 meters, that cannot be reused or re-terminated or redeployed, and essentially becomes waste. So the reason that's difficult to solve is first, of course, it's a low material, it has low material value. So fiber cable is mostly plastic and very, very small microscopic pieces of glass. That once processed does not have a high financial value or any financial value at all, which isn't enough to offset collection, recycling, processing costs, etc. The second is that on-site termination isn't viable at scale. So of course, we could look at using drums of cable where we can pull to certain lengths and terminate these cables on site with engineers. But it increases faults in the network drastically, which again increases our emissions and reduces our circularity, less installation rate. And slows our installs. And third, pre-terminating both ends is something that we've looked at too. Can the part that an engineer cuts off then be reused for a different install? And it actually makes it worse. So we end up with very short lengths that then cannot be used. And instead of just wasting the cable itself, we're then adding a connector, which then ends up not having a use case and ends up going to waste. And fourth, the recycling options are extremely limited. So non-terminated drums sometimes can be reused. We retest those drums, send them back out into the network when they're not pre-terminated. but something that needs a pre-termination point cannot be currently reused. So fibre waste is really a cost and not a commodity. So the question is this: how do we deliver a national fibre rollout at record pace, providing the UK with the amazing digital infrastructure that reduces all of our emissions from being able to work at home and all of the wonderful benefits that it provides and digital inclusivity, but also using pre-terminated cable to guarantee quality and resilience without creating a waste stream that cannot currently be reused or economically recycled. It's not doing the wrong thing. It's the fact that engineering and operational logic is sound, but this is where the next wave of circular innovation needs to happen in the design, the material science, and the supply collaboration on the fibre material itself in those cables. And that's why conversations, of course, like today really matter. Thank you.
Andy, thank you so much. That's a really interesting and complex challenge, isn't it? And it really just shows those tensions between efficiency, operational gain, finance versus sustainability, material use, and definitely that tension between the value in the copper against the perceived value of fibre optic cable. And the challenges around it. Fantastic, thank you. And our final speaker today is David Greenfield. David, I'm wondering how I should introduce you, President of CIWM, and then I think I'll let you take away with any of your other hats that you'd like to throw in. Oh, you're on mute at the moment. We can see your slides.
There we go. Hello, sorry. Thank you very much, Georgie. And yeah, I'm just going to put this on full screen so you can see the whole shebang. I'm just going to take you through a little bit of the motivation and some of the things that are going on. I won't go through all my different roles, but a few of them are there. I'm an ecopreneur. We've got 3 businesses focusing on circularity, some of which are picking up digital, President of CIWM, Vice President of Circular Economy Institute, and member of the Government Task Force. So a lot of what this is about materials. As President of CIWM, I launched my report last summer on lost opportunities, winning back materials to drive the UK circular economy. QR code linked to it if you want to read the 329 page. Fundamentally, waste is a design flaw, so we need to try and recover some of these materials. We're losing lots and lots of materials across multiple sectors at the moment. And the UK is very well positioned to lead on that. Why is this important? We are using so much virgin material at the moment, huge amounts, and we're not getting any of it back. We've got a very low circularity rate at a country level, but across the globe it's not great. We're still putting 56% of household and 65% of commercial industrial waste into the residual waste stream. That is either landfill or energy recovery. And globally, we're losing our circularity opportunities. So government put in place in November 2024 a Circular Economy Task Force, of which I was one of 15 members that was asked to join from a variation of industrial, business, academia, and third sector. And essentially, over the last year, we have built and consulted on the creation of a circular economy growth plan, which will be coming out imminently. Government is committed to economic growth and green jobs, using circularity as a tool, and to recover and use our resources as efficiently and productively as possible. I've tried to consolidate everything that DICE has the opportunity to do into a single table. I'll leave this with you to explore and to contribute, but essentially, if we look at circularity through the business model lens, there's 5 different business models. Circular inputs: how do we change the materials that are going into the systems we use? How do we extend the systems and products that we already have? How do we share what we've already got, or how do we plan for sharing what we've got? How do we actually convert from consumption to product as a service? And then at the end of use, end of life, how do we recover? Digital leverage points hit all 5 of those business models in slightly different ways. And the example applications are also multiple. So I'm not going to go through all of these. You can have a look at these. But for me, this is where digital and circular circularity really coexist. We need to use digital to enable circularity, and that's where these sorts of funding calls are really key. I'm going to give you one other example of something that's going on. We're leading with my Tech Take Back hat on the creation of a hub for circularity across the southeast of England. It's part of a European 25 million euro partnership, 44 countries, etc. And we are setting up industrial symbiosis of stranded materials currently deployed as waste. Ultimately, we are creating a live demonstrator of how you can use digital to enable industrial symbiosis. This is one of many things I'm doing at the moment, so trying to get it all into 5 minutes is quite tough. But for me, I think GAIS Plus is a really good opportunity to collaborate between lots of sectors and partners that may not be able to otherwise, and try and go forward and make the circular economy a digitally enabled solution. So that's me. Thank you very much.
Brilliant. Thank you so much, David. Really helpful there to also have that policy perspective and understand that the sort of top-down focus on circularity as well. I'm very mindful of time, so I'm going to keep moving forward. And Lirong, I think, is going to speak now just a little bit more around sort of developing those collaborative proposals and projects. Lirong, are you with us?
Yes, I'm here. Thank you, Georgie. And Kate, can we move to that slide, please? Okay, here. Yeah, I'm just here to share this news with all of you. We will have another workshop in March to around how to strengthen your applications. And during this interactive webinar, we will introduce how to respond to different application criteria, and we will invite previous successful funding application researchers to share some really practical tips for collaborative proposal development. And there's also opportunities to use the EDI card developed by our EDI lead, Ali, and to strengthen the EDI considerations in that webinar. So we have run this before and we got really positive feedback. So please feel free to register and join us. And we look forward to see all of you in that webinar. And I will hand over back to you, Georgie.
Thanks. Thank you, Lirong. That's brilliant. Yep. And I've just popped in the chat the registration for anyone who's interested, so you can register for that session. And we've got a few minutes now. So if there are any questions, feel free to put your hand up, and you can come off mute and speak, ask questions of any of our speakers today, or pop your question in the chat if you would prefer to. Just trying to multitask and have a look through the chat. I don't think we've got any specific questions other than, yes, the slides will be shared after this event. Great. Minnie, go for it.
Oh, yes. Can I check regarding the requirements for the proposal? So do we need an academic collaborator to lead the submission, or how does this work?
Yes, yeah, you do. So I can share the details with you. They're all on the website. But yeah, it needs the funding because it comes through EPSRC, so fundamentally UKRI. You have to be an institution that's eligible to receive UKRI funding to be able to lead the project. But very much our focus is on having collaboration with partners outside of academia on these research projects.
Thank you.
Georgie, I've got a question from a colleague who's looking at this around the FEC threshold, and I know it's 80% for the university. Could you just explain that a little bit more? Because for all of us that are outside of the university, we need to collaborate with the university, and just explain, I think, for those, a better understanding of how a partnership may be able to work.
Yeah, I can do my best as a slight novice in this area as well, but absolutely. So the 80% FEC is really so the lead institution would be expected to pay the 20% balance. Where we have projects where we've got non-academic partners, you might be contributing either with cash, so they might be putting funds into the project additionally, or it might be in-kind donations, so that might be through time. Particularly when we consider demonstrated, it might be access to materials or labs or specific equipment at a kind of on an in-kind basis. But that wouldn't necessarily fall within that funding. So it's the direct costs of the project, so as in the cash that needs to be expended, which goes into the 100%, 20% of which the institution would be looking to cover, and 80% would come from the DICE funding. And that's a roll down basically from the EPSRC funding requirements. Does that answer that question?
Yes, that's fine, I think. Thanks, Georgia.
Thank you. Sudhir, hi.
Yes. Thanks everyone. That was very fascinating, very insightful. Actually, I had quite a few questions, but I'll confine myself to one, mainly to Stefan Larsson. Very excited to hear that you're actually talking about the water challenge and the energy challenge and the materials challenge in terms of, a whole system design kind of approach of looking at all three of these kind of overlapping, sometimes in tension. Did you, in your experience, do you think it's easier to do these kind of cross-sector collaborations for water? How is it shaping up for energy? Because from my understanding, I mean, I don't work within the sector itself. I'm just an academic researcher. I find that it has worked well for water. It is beginning to work well for energy, but for the material space, it's not even there yet.
Yeah, no, that's a brilliant question, actually. I think right now we are challenged in all three areas, to be honest. I don't think we found the solution yet on water. I don't think we found the solution yet on energy and again on raw materials. That's why we in Lenovo, as I said, we try to figure out how to solve some of these challenges. What I didn't mention was also the fact that we use quite a lot of renewed materials in our products, both in terms of plastic and metal and stuff like that. So that's one way. We also have a very comprehensive recycle program where we can take back old units and recycle them, either use the components or use the whole machinery, all depending on the quality and state of that unit. But the matter of the fact is, when we look at this in a bigger perspective, I think especially around power, that can be one of those future challenges. With the increasing use of AI, we just know that's going to be one of those challenges. And the matter of the fact is that, as I said, I'm not a strong believer in we can limit users for not using AI, because I think that's going to be close to impossible. So we need to solve the power challenge, and we can do that in many ways. We in Lenovo, we try to do it with the Neptune servers, and we don't stop here, of course, but as one of those solutions, basically designing products that uses less energy in a smarter way, but also that we can take it to the next level, that we can actually reuse, as I said, the warm water, or reuse the energy, or however. So your question is absolutely spot on. It's in all of those three areas that we really are working. And then last but not least, because I think that's another key area here, when we talk about sustainability and we talk about sustainability solutions, there's no doubt that the key factor here is also the easy to implement that solution. Because if you as a company cannot or have difficulty implementing a given solution, the likeliness of that solution being successful is not really going to happen. So, all of these elements are extremely important, but with the focus on all of them at the same time.
Fantastic. Thanks, Stefan. Do we have any other questions? Diego, you look like you might.
One, Sonic is on. I don't know if you want to come out from mute, Sonic, to ask it yourself, or if not, we can ask it for you. But
yeah, cheers, Diego. It's for Stefan Larsson also. Again, thanks for your presentation. what I hear you suggesting is essential industrial symbiosis for district heating as the end solution of utilizing more of this heated water. It's something that's already been tested, been used in Helsinki. We know the Kalundborg symbiosis. We also know it's a big theoretical thing from talking circular economy. What I didn't understand from your presentation, what do you see as the actual problem here? Is it governance? It's policies? It's where do you perceive the main barriers and the problems here? Drivers is obvious.
No, that's a wonderful question as well. And the matter of the fact is, if I had one clear answer to that, I think it would be much easier. I think it depends on the region, it depends on the country, and then it depends on even on the company. Because this solution is not an easy one to implement in the short run, but definitely very, let's say, feasible in the longer run. So from my point of view, when I look at this, it should be one of those things that should be, let's say, included into every new building that are being built or every new company that are being built as a standard, that you need to think that extra thought in advance that we have this capability. On older buildings, it can be a bit of a challenge, but on the other hand, that is where we are right now. You need to think in new ways of doing it. So to come back to your answer, I don't think there is one clear answer. I think it's a combination of all of these, but definitely there is the encouragement, or there could be the encouragement of some kind of a discount for more sustainable solutions going forward.
All right, thanks.
Fantastic. Thank you, everybody. I'm really mindful of time, and we're just about a minute away from 1 o'clock. So to allow everyone to get away for lunch, I think we've just got very briefly a couple of final slides just to skip over, which just has the timeline. I'm not sure, Kate, if you're able to share those. Just so I can touch over the timeline for the feasibility studies and demonstrator calls. But in essence, we're at the 18th of February now. We've got our workshop, as we mentioned, which will be on the 12th of March. The application deadline then is the 27th of April. So that's midday on the 27th of April that we need all applications in for the next round of demonstrator and feasibility studies. We'll then be announcing the shortlists on the 20th of May, and both of those shortlists will then go through a panel pitch day. So that's an in-person day for the feasibility studies where you get to present to a board. That's on the 2nd of June. And then on the 17th of June, it'll be held online for the demonstrators. Thank you, that's here. And we're looking really for projects to be kicking off at the beginning of September with a 6 to 9 month term, so wrapping up by the end of June 2027. So those are the key timelines, and like I said, we'll share these slides afterwards as well. And I think the final slide here is really from Kate, Diego, myself, Fiona as the network lead. We're here to support. So if we can support in any way with project development, mentoring as you're developing your proposal, like we said, we've got a really strong team of industry and academic partners who are there to support, and also networking, this event being one of those pillars. As Kate's popped in the chat, we also have this collaboration notice board, which is open to industry, policy, third sector partners, any kind of research teams as well. You can pop your challenge focus or your project idea and research area up there, and that just helps people connect, and hopefully you'll find that a useful resource. It's a resource that we ran for our first call and found to be really effective, so do please make use of that. So thank you so much to all our speakers today. I hope you found it a really, really useful session. And please do reach out as you move forward with your project development. And if we can help in any way, that would be brilliant. So wish you all a very good rest of the day. Thanks.
Thank you.
Thanks.
Thank you.
Thanks, bye.
Bye.
Thank you. All right. Have a nice day. Thank you very much.